Okay, here's warm-up number 43. We're going to factor these trinomials completely. So first thing I would look for on any of these is if there's a common factor. Does anything go into all three of these terms? Nothing does here, so I'm going to use a diamond problem. There's lots of different methods, of course, that you can use. But I'm taking the B and putting it up there, and then the C, that number at the end, goes at the bottom. Now I'm looking for two numbers that are going to add together for 2 and multiply the same two numbers. The product is negative 15. So thinking about ways to multiply to get 15, I could do that, but those don't add up to 2. These don't add up to 2 either. But if I use a 3 and a 5, one of them has to be negative for them to multiply to negative 15. And this is my winning combo. That's the two that are going to add up to positive 2. So I'll put a negative 3 here and a 5 there. Okay, and what that does for me, I know when this is factored, it's going to look like this because the x's will multiply to get x squared. I'm just interested in what's in the back, and that's what the diamond problem does for me. These two numbers will go in the back of the parentheses, and now this is factored. You could have those same two factors in reverse order, but the 3 has to be negative and the 5 has to be positive. Okay. On the next problem, I do have a common factor. All three of these terms are even, so I can factor out a 2. So when there's a common factor, factor it out right off the bat. So I'm kind of thinking about distributing. 2 times something equals 2x squared. That would be x squared. 2 times something is 12x. That would be 6x. And 2 times something is negative 32. That's negative 16. Okay. Now what I can do with the trinomial that's left in the parentheses, I can factor that in the same way I did the last problem. Okay, so it's going to look like this. I just need to figure out what goes in back. So I'll set up a diamond problem again. And I'm going to use the 6 and the negative 16 because I'm factoring this trinomial, not the original. So 6 goes up there, negative 16. I'm adding to get 6, multiplying to get negative 16. So let's think about this. We could use a 1 and a 16. One of them would have to be positive, one negative. That's not going to work. How about a 2 and an 8? And I can do something with a 2 and an 8. If the 2 is negative and the 8's positive, that's my winning combo. There are other combos, 2 and negative 8, or you could do a 4 and a negative 4, but that's the only one that the two numbers are going to add up to 6. And that's what goes in the back here. Okay. All right, next one. So this time I've got a number in front of the x squared again, but this time I can't factor it out. So this gets a little more complicated. You can still use a diamond problem, but you have to do what I call a modified diamond problem. So if you can't factor out the 2, take it and multiply it by the negative 9 to form a new trinomial. So this will just be x squared because I'm kind of moving that 2 to the end. And then 2 times negative 9 is negative 18. Okay? So now I'm going to factor this trinomial with a diamond problem. Okay? And you don't have to write out all the combos down here. If you find one that works, then there's only going to be one that works. So thinking about this, 1 and 18, I can't get a 3 out of that. 2 and 9, I can't get a 3 out of that either. But 3 and 6, I can do something with 3 and 6. So if I had 3 and 6, the 6 would have to be negative and the 3 would be positive. So that's what goes in the back here. Okay. Now, that's not my final answer because if I multiply it back together, I'll get this red trinomial, not the original one. Okay? So I changed the problem, so now I've got to change this answer. And the way I'm going to do that, since I multiplied by 2 at the beginning of the problem, sorry, I'm trying to reach for a pen as I'm doing this. Now I'm going to do the opposite. I'm going to divide by 2. I'm just going to divide the number parts by 2. Just those two parts. Okay? And then I've got this fraction. I want to reduce that as much as I can. I can't reduce 3/2, but I can reduce negative 6 over 2, like that. Okay. Now, in this first parentheses, when you can't reduce the fraction anymore, take the denominator, pull it out in front of the x, like that, and then the 3 will fall to the ground. And then here is our final answer. And if you're not sure, you could always FOIL it together, multiply it back together. You should get 2x squared minus 3x minus 9. Okay, number 4, different type of problem. Write an equation in slope-intercept form. So you got to know slope-intercept form is y equals mx plus b. So I need to figure out what the m and the b are here. Okay, so I'm going to call this my original line. Okay, and I can see what the slope is because that's already in y equals mx plus b form. So the slope there is 1/3. Okay, so my new line, the one that I'm actually writing the equation for, is going to be perpendicular to that given line. Okay, so you got to know that if they were parallel, they'd have the same slope, but perpendicular lines are going to have opposite reciprocal slopes. So you take the fraction and you flip it upside down, which would give me 3/1, or just 3, but you also take the opposite sign. So -3 would be the perpendicular slope to 1/3. Okay, so my new line's going to have this slope, so I know the m part already. I just got to figure out the b now. Okay, so let's start writing an equation just based on this. So y equals mx plus b. I know the m part. So it's going to be y equals -3x plus or minus something. Just got to figure out what the something is. That's where this is going to come in. Okay, so this is going to be an xy pair. I'm going to plug that xy pair into my equation here. I'll put in 1 for y, and I'll put in 3 for x. And now I'm going to solve this for b. Okay, so 1 equals -9 plus b. And then I'll add 9 to both sides to isolate the b. And the b is 10. Okay, so now I know both the m and the b. So I'm going to go back to, well, I guess I could use this one. I knew it was y equals -3x plus something. Now that something is 10. So y equals -3x plus 10. And that is my answer, and that's the end of the warm-up. And I'll see you next time.